Good day, ladies and gentlemen. My name is Peter and welcome to the first tutorial in a series of camera controllers. In this video, we'll be looking at creating a spectator camera for use in your first-person shooter project. We will be able to fly through our scene and get a nice overview of our surroundings. So let's start off by creating our project. We'll go ahead, say new project. It's going to be a 3D project and we are going to name it camera control tutorial. Okay, and basically what we'll do is this is going to be our main project for this entire series. We'll be using this to basically house all of our camera controllers in one project. Okay. So first off, I keep getting this error in my Unity, error loading launcher. I do not know why this is, and it's every time I create a new project. If anyone knows anything about this, please give me a comment. I would like to know what's going on here. Anyways, let's get back to our project. So first off, let's go ahead and creating a folder structure. Just to keep things neat, what we'll do is we'll create a folder and call this lesson 1 Spectator, and inside this folder we'll create another few folders. The first one we are going to call prefabs. This is where we are going to store our game object as a prefab so that we can easily use it later on in any other project. The second one will be our scenes. That's just to save the scene in, makes it easier to load later for a sample. And the third folder will be our scripts. Okay, so first off, let's quickly set up our scene here. What we'll need is, first off, we'll quickly need something just to visually see what happens. We'll add a cube. I'm just quickly gonna create a little, I don't know, obstacle course or something. We'll make it like that, make it nice and thin. Add another cube. Oops, that's an empty game object. Let's say cube. We'll move this up, duplicate it a few times just so that we have a nice scene. Just you can visually see what happens whenever we move around, and there we go. Okay, then what we'll need, I'm just quickly going to add all this into an empty game object just to keep it nice and neat. This is not necessary, you can have your own scenery to use this in. I'm just quickly building something because, well, this is just to show you how to do this. Okay, so first off, what we'll do is we are going to create an empty game object. We will reset the transform and we'll call this Spectator. Okay, what we are going to do with this, we are going to add the camera to it, reset the camera's position, and that's just basically so that whenever we move around the spectator, we'll basically be able to move the camera as well without any effort. Okay, so let's go ahead, and for the spectator we'll add a script. I'll actually add it through here. Go into the scripts folder, create. I'm using C#. Feel free to follow along with JavaScript, although I will be using C# in all my videos as I'm not familiar with JavaScript. So let's add our script and we'll call this spectator controller. And before we enter our script, we'll just quickly add our spectator to our prefabs folder and also add our script to our spectator. Just make sure to apply so that it adds the script to our prefab as well. Okay, then we can go ahead and open up our script. Now do know that the way I'm doing this, it's not necessarily the best way of doing it, but this is my way of doing it, and so far it's proven quite useful to me. So when you have your script open, first what we'll do is we'll just clean up some of this. We'll keep the update method, as we'll be using that for our movement and so on, and then we'll add a few comments. First off, it's going to be our public variables as well as our private variables. Okay, for our public variables, what we'll do is we are going to add a header. Now this is a nice function of Unity Inspector. We can add headers to variables so that we group them together in the editor. First off, we'll have the movement variables. Underneath here, we'll start off with a public float, our slow speed. Basically what I want to do is I want to implement so that we can either move slowly or fast. We'll do that by using a button, something like shift or so. So what we'll do is public float slow speed is equal to, let's set this something like 8 units per second, and then another public float fast speed, and we'll set this to something like 15 units per second. Then what we are going to need is something to smooth out our movement. Now one way to do this is you can use Unity's own smoothing on your input, although I find that sometimes it does not work perfectly, so we'll use our own smoothing for this. Basically what we are going to need is we are going to have a public float move smooth factor, and we'll set this to a value like 0.75. And what we'll do, just to make it a little bit better and better looking in the inspector and also more realistically, we'll clamp this value between a value of 0 and 1. Okay, and that is basically our movement variables. Up next, we are going to add a header. We'll call this rotation, and this will be all the variables we need for our camera rotation. So first off, we have a public float pitch sensitivity, and we'll set this to a default of 10. We'll have a public float your sensitivity, and we'll set that to a value of 10. Then for our pitch, that's basically looking up and down, I like to clamp this value just to ensure that you can't look all the way around and end up looking upside down at the world. So what we'll do is in between here we'll add another 2 floats, call it public float the minimum pitch. We'll set this to -90 so that we can look all the way down, and public float maximum pitch, and we'll set this to a default of 90 so that we can look all the way up as well. Now you can change this to any of the values you think is perfect, like maybe you don't want the player to look all the way up or all the way down, but that's all up to you. Then for our rotation, what we'll do is we'll also add a range from 0 to 1, and this is going to be our public float rotation smooth factor, and we'll set this to something like 0.15 usually works for me. And let me just quickly ensure that we have everything that we need here. Yes, that seems like it's everything. Okay, now let's move on to our private variables. Our private variables will basically just be temporary stores for stuff like our current velocity, target velocity, basically just to store where we are at and where we are going. Basically what we'll need is a vector3 for our current velocity, a vector3 for our target velocity, a vector3 for our current rotation, and a vector3 for our target rotation. Another one we need is for our current speed. Now this is not the speed that we are traveling at currently, although we will name it this way because this is the current speed that we'll use when we multiply our movement input. Okay, so first off, we are going to need 3 different methods. You can do all of this in the update, but I like to keep things neat. So first off, what we'll do is we'll say void handle input, void move, and void rotate. And those are the 3 methods that we'll need, and we'll also add them to our update method, just to ensure that they get called every single frame update. And there we go. Now let's start with handling our input. First off, what we'll do is for our movement, we'll say the target velocity is equal to our let me just quickly make sure here, our target velocity is equal to a new vector3, and we'll call the x would be input.get axis raw. Now this is basically what I mean by we can use either Unity's smoothing or our own. Whenever you use the get axis function, it gives you a smooth value, smoothed out value of the current axis. So if you have a joystick and you push forward on it, it would give a smoothed out value between what we had and what we are going to. I like to use get axis raw, as this gives a nice firm, constant, instant movement, and then basically we can just add our own smoothing factor to change whether we actually want the smoothing or not. So for our x value, we will use the horizontal axis. For our vertical, or actually our up and down, we'll use let's see, for this we'll have to use an axis, although we'll have to go create it in our input, but we'll say this is going to be our jump axis. And then as well for our forward movement, we'll say get axis raw, and we want the vertical axis. Now this is basically the horizontal is when you press A, D, left, right, or move the analog stick to the left or right. The jump, we will adjust that to be on our keyboard, the Z and X buttons, Z being down, X being up. And vertical is when you press forward or backward on your joystick or keyboard. That would be your W and S keys. Then basically what we want to do, just to ensure that you don't move faster in a direction whenever you press multiple buttons, we'll normalize this. And then just save our script. And then what we'll do is, let's see. Okay, now what we want to do is set up our current speed. So our current speed will be equal to the input.get button run, which we'll also go set up ourselves in the Unity input in a bit. So input.get button run, and we'll add a question mark. This basically causes the script to validate whatever we put on the left hand side, which should return a true or false, and it'll basically sort it out. Whichever is directly to the right of the question mark will be your true value, and then it gets separated by a colon, which then on the right hand side of the colon would be your false value. So on the left hand side, if we press the run button, we want to use our fast speed. If we don't press it, we want to use our slow speed. Okay, so that gets that set up. Now for our rotation, what we'll do is we'll say our target rotation is equal to a new vector 3, and we'll set this up as for our up and down, so we want to rotate it around the x-axis. We'll say mathf.clamp, and this is now where we're going to use those clamping values. We'll say target rotation.x plus our input.getAxis mouse y, and we wish to clamp this between our minimum pitch and maximum pitch. Okay, then for our next value will be our y value. For this one, this is easy. We'll just say the target rotation dot y plus the input dot get axis mouse x, and then basically what we can do is, yeah, that's basically that. We don't use the z value, although you can go figure out to add basically roll functionality. That would be useful for space games or so, but in our case we just need a standard floating first person controller. So what we'll do in the input, and this is only in the input, we'll go ahead and multiply our input by our let's see, this is now the pitch, so we multiply this by our pitch sensitivity, and the x, well, the y value will multiply by the yaw sensitivity, and there we go. That's basically all our input set up. Now on to the next function. We'll first do our movement. Okay, for the movement, it's actually quite simple. Basically what we need to do is we need to say our current speed is equal to a vector3 dot lerp between our current speed, oh sorry, not our current speed, it's our current velocity, is equal to a vector3 dot lerp between our current velocity, and then we'll use our target velocity multiply by our current speed and multiply by time dot delta time, just to ensure that we are moving in units per second, and we will basically lerp this value with our move smooth factor. That will give us a nice smooth movement, and then we can just say transform dot translate current velocity. As simple as that. And at this point we can go ahead and quickly set up our do we want to, no, let's quickly finish the script first. Okay, basically for the rotation it's also quite simple. Let's quickly set it up. Our current rotation is equal to a vector3 dot lerp between our current rotation and our target rotation, and this will also be this does not need to be multiplied by any values, although we do need to use our rotation smooth factor value. And then all we have to do is we have to set the transform dot rotation is equal to a quaternion dot Euler of our current rotation. And there we have it. Our entire Spectator controller script is set up. Basically what you can do, however, this is optional. You can say you can use the start method. We'll just add a void start, and we can say cursor dot lock state is equal to cursor lock mode dot locked. Now all this will do is whenever you enter the game as a spectator, your cursor would automatically be locked to the center of the screen, and you don't have to worry about moving it too far to the left, too far to the right, or whichever. That basically gives the perfect first person feel. Okay, so with that all set, let's quickly go ahead and set up our run and jump inputs. Okay, back to our Unity. Let's go ahead and go to Edit, Project Settings, Input. We'll look to the right and we'll open up Access. And for this, what we'll basically do is we'll take the vertical, we'll duplicate it, we'll open it up, and we'll change the negative value to Z, the positive value to X. We'll remove the alternatives, and we'll change the name to jump. Okay, then the other one we need is for run. For this, we can simply take fire1, duplicate that, then we'll go ahead, change the name to run, change the positive button to left shift, and if you want to, you can use a mouse button as well, but we don't want to. Our gravity, we'll set it to be 3, sensitivity to 3, and we'll enable snapping. There we go. That's basically all our inputs set up as well, and with that we can basically go ahead and test out our new Spectator controller. So let's hit save our scene. We'll basically go to lesson 1, scenes, save it as Spectator scene. Let's hit play, and as you can see, we can look around. One thing to note is I'm moving the mouse down and we are looking up, moving the mouse up and we are looking down. Now this is basically just the rotation being inverted. We can simply go ahead and change that in the script in a minute, but as you can see, we can look around, we can travel. Whenever we hold the shift key, we'll see that we move faster, slower without it, and pressing Z means we go down, pressing X means we go up, and pressing escape while in this mode will reveal the mouse. So then we can just hit stop and quickly go ahead. I think what we are going to do, as there's still some time, we'll add a, let's make it an option to invert the rotation. So let's add, below the pitch, we'll add a public bool invert pitch, and we'll set this default to true, as well we like to move the mouse up when we look up. So what we'll do is we'll simply go to our handle input, target rotation, and in the clamp value we'll simply add a bracket around our input.getAxis y, and what we'll do is we'll simply say multiply by another, let's see, do we want to? No, actually let's leave out the extra brackets, and we'll simply go ahead and add in here multiply by our invert pitch question mark to validate it, and we'll say -1 or 1. Now as you can see, this gives an error. All we have to do to fix that is just add brackets around this, and therefore when it won't try to multiply by invert pitch, but instead whichever value gets returned here. So now if we save this, head over back to Unity, we press play, you can see that moving the mouse up means we are going up, moving the mouse down means we are going down. And as simple as that, we have a fully functional spectator camera for a first-person controller, or well, pretty much anything. And that's that for this tutorial. Thank you guys for watching, and please like, comment and subscribe, and we'll see you again in the next lesson.